We all know what this is, right? Looks like a magnet. This is our beginning unit on magnetism. This is the first section. Magnetism is always really cool. We all know, we've all played with magnets from kids, when we were young, and we all know that if you bring something metal close to a magnet, it'll automatically be attracted to it. Or if I just get it close, it looks like everything's floating, right? It's always mystifying how that happens. How does it not just fly away? Oh, fell off. But if you get it close, you get it back. Well, in this unit, we're going to study magnetism, and you're going to learn a lot more about it and how it works. So let's just jump right into our presentation. Move myself down. All right, so this is a presentation one, our very first one on magnetism. Our learning targets for today's presentation will be that you'll be able to describe the qualities of a magnet. You can identify the poles of a magnet, and you can explain the magnetic force field surrounding a magnet. Now, we're going to be taking notes, and this is where your slotted notes begin, at the very, very beginning. Sorry, I got to move myself around here because some slides are full and some aren't, but I'll just move myself around so you can still see me. So here are our state standards, what we're going to be learning in this unit. And I won't read it to you. You can pause the video now and look at it if you'd like. But I'm just going to just keep rolling. All right, so magnetism. Magnets. What are magnets? Well, magnets are any material that attracts iron, nickel, or cobalt. Or it's materials that contain iron, nickel, and cobalt. We'll know that, please note that magnetism is closely related to electricity in the ways of attraction and repulsion. If you remember back to the law of electric charge, that law still applies to magnetism, and we're going to see that as we move through. So the basics of magnetism. The term magnet actually comes from an ancient Greek city in Turkey known as Magnesia. That's where they dug in the ground, they noticed that these rocks would attract to other metals, and they were known as lodestones, which lodestones contain magnetite. Now, you don't have to remember all of this history about it. This is not going to be on your test or anything, but it's good to know the history of magnets and where they come from. That's the reason we call them magnets, if you look, because it contains magnetite, and it's actually from Magnesia in Turkey. So that's just why we call them magnets. Now, force. Now, if you think way back when we were studying forces, you'll know that our magnetic force, or just any force, is just a push or a pull. Now, that pull is known as attraction, like in electricity, and the repulsion is a push, like in electricity, when those electrons were spinning and moving and causing negative charges to push away from negative charges. When we did the static charge, and we got the electrons on the balloon and we moved it to the wall, it would push back all the negative charges and bring forth and attract or pull in all the positive charges, and it would stick to the wall. So that in the same way, magnets do that same thing. If I have this piece of metal, which is a paper clip, far away from this magnet, the magnet has no bearing on the metal whatsoever. But as I move it closer, you can see that the attraction is stronger. So the closer they are, the stronger the attraction, and vice versa. The farther apart they are, the weaker the attraction. So it's pretty common sense. All right, so just like magnetic poles, well, you can see this. So just like magnetic poles, like electric charges, positive and negative, magnets have the stronger part of the the pull and the weaker part of the pull. And if the strongest part is around the ends of a magnet, or on a side, like if they're round, you have one side and then you have another side. And we call those poles. We know them as North Pole and South Pole, which in later presentations we'll see how the Earth has poles. But just like the law of electric charge, we know that like poles or like charges repel. They push away. You bring them close in and you can't touch them, because if you do touch them, they'll just push each other away. And opposite poles, north and south, when they get close together, they attract, and they make a strong pull toward each other. Now, something that you probably didn't know is that if you were to take a magnet that has a north pole and a south pole, such as this magnet here, you got a magnet north pole and a south pole. Now, if you were to take that magnet and break it in half, what you would actually do is kind of like when you cut a worm in half, and then the worm grows its tail back. It becomes two separate magnets. When you break that magnet, that each piece that is separated now has its own north and south pole. So now, instead of having one magnet with one north and one south, you now have two magnets, one with the north, one with the north and south, and the other with north and south. So now you have two magnets. And if you bring those two pieces and you bring the two north poles together, they're going to push apart. And likewise, if you bring the opposite pole, they're going to attract. Thought that was pretty cool. Now, around the magnetic field, around a magnet, we have a magnetic field, and it's greatly represented in these pictures here. So we got, like, this one is really good because you see the arrows. The way the triangle is pointing is the force of attraction. The north is being attracted to the south, and vice versa. But as you can see, this is the way that the lines move, the invisible fields that we can't see. This is the area around the magnet that act, that pull in. And when they're closer together, like at the poles here, see how closer together, they're a lot stronger. And you can see it in this diagram too, where the arrows are pointing toward the pull, the pulling power. So we'll actually look at this, and you can do an experiment to put lead shavings down, and you can actually see the magnetic fields, and it's actually pretty cool because now we don't see this in real life. Like, here's a magnet, and I'm holding it up to the camera so you can see, but you don't see these magnetic field lines, right? You don't see them because they're there, but they're invisible. Kind of like science fiction. Somebody uses a force field to push something back. This is exactly what happens in magnetism. Just like this paperclip's attracted to this magnet, we can't see the fields around it that are attracting it, but they're there just the same. It's pretty cool. Magnetism is really fun. So, looking through this presentation, we see that a magnet is any material that attracts iron, nickel, or cobalt, or it's a material containing iron, nickel, or cobalt. Plastics usually aren't. Plastics aren't magnetized. We know that there are some substances that are magnetized and some that aren't. And the ones that are usually are metal, and the ones that aren't are usually everything but metal. Glass, plastic, cloth, same things like that. Now, each magnet has a magnetic pole, a north and south region, where the magnetic force is the strongest. And if you bring the opposite poles together, they attract. And if you bring the similar poles together, north and north or south to south, they will repel, just like the law of electric charges. And a magnetic field is the area that surrounds a magnet where all the forces pull in, and is represented by a picture like this. It's very good representation. So that's our notes for this first section. If you need to go back and watch the video again, you may. If there were sections that you missed or something I went too fast or you need a little bit more explanation on, you can always go back and pause the video and read it again.